Okay, guys, so I'm working in section 5.1 today. You should have your notes from up on the board, and we're going to start talking on page 250 on example 1. Okay, so you should have all your notes down. You should know the pieces, and now we're going to practice some different examples of each one. So the first one I'm looking at is example 1 over here. Okay, we start out with y equals 2x squared minus 8x plus 6. Oops, sorry, positive 2x squared. Okay, so the first thing I have to decide is what form this is in. And remember, I have standard, vertex, or intercept form. This is in standard form because I have ax squared plus bx plus c. So if I want to pick out, I have a equals 2, b equals negative 8, and c equals 6. Okay, so now if I go through my steps, the first step is, does it open up or down? And in our notes it says if a, which is 2 in our case, if a is greater than 0, it opens up. So a is greater than 0, 2 is greater than 0, so it opens up. Step 2 is to find the vertex, and for our x-coordinate it says take negative b over 2a. So in this case, our b is negative 8, so that would be a negative of a negative 8 would make that positive 8 over 2 times a is 2. So we'd have 8 over 4 or 2. To find the y, we actually sub this x back into our original equation. So we would put 2 in for x here and have 2 squared times 2 minus 8 times 2 plus 6. But an easier way to do that is we can use our graphing calculator. And if you turn your calculator on and you go to y equals, and I know there's kind of a glare there, guys. I'll do the best I can. Okay. All right, so under y equals, which was right here, I'm going to type this equation in. I don't need to put the y equals that was at the top of our board because that's already there. That was the button we pushed. Okay, but I'm going to type in 2x squared minus 8x plus 6. So I'm typing in my original equation from example 1. Then to be able to find a value, meaning to be able to find y, I'm going to go to second trace. So second trace, and they give me this list. I want value, so I'm going to hit enter there. And you'll see it graph. Now, mine's not great. Mine's real skinny. It really doesn't matter. I don't need to see the whole graph, but it might be nice to have a better idea. My window that I would like you guys to have most of the time is negative 10, positive 10. Negative 10 goes on your mins, positive 10 goes in your maxes. Okay, you can see that my y min is negative 10 and my y max is positive 10, so I'm okay there. Sometimes you have to change it. Like if you need to see farther to the right, then you need to change your x max. Okay, if you need to see farther up, you need to change your y max, and so on and so forth. Okay, but it should work for us today. So let's go back to second trace, and you'll see it take its time to graph. Okay, so that's a better graph. Oops, did I not hit second trace? There, second trace, and I went to value, and it's saying x equals. Well, what was the x that we got for our vertex? We got 2. So if I hit 2 in there and I hit enter, now it tells me that y is negative 2. Okay, so I'm going to put that to the side. So now I know the ordered pair for my vertex is 2, negative 2. The x was 2 and the y was negative 2. And I'm going to go ahead and draw that. Okay. Step 3 in my notes was axis of symmetry. Remember, this is a dotted line through the vertex that's going to cut my parabola into 2 parts. So I just draw my axis of symmetry. Some people draw it all the way through theirs. I like to draw it up or down, and then it reminds me later on if if I've done my parabola right. Okay, it kind of is a check for me. So I know that mine should open up from step 1. So I'm just going to draw a dotted line up from this. Okay. All right, now step 4, I'm ready for an XY table. Now I can pick any x's that I want, any 2 x's that I want, as long as they're on the same side of the axis of symmetry, meaning I could pick anything over here, or I could pick anything, remember this is right in the middle, sorry I didn't draw that very well, or I can pick anything to the left-hand side. I like to stick with 0 and 1 if I can, so I'm just going to put 0 and 1 into my XY table. Now remember, again, to find the y's, I can go back up here and I can sub them in manually, meaning like do it by hand, or I can use my calculator. I already have this into my calculator, and remember, it will find values for me. If I didn't touch anything, I can just hit 0. So now it's saying, what am I going to get if x equals 0? And it tells me y equals 6. Okay, now if you did touch something on your calculator, remember you're going to have to go back to second trace and then go to value. It's going to ask you what x equals. My other one was 1, and I get 0. Okay, so now my XY table looks like 0, 6, and 1, 0. So let's go ahead and plot those points. 0, 6, and 1, 0. Okay, step 5 says that I'm supposed to mirror these points. When I'm talking about mirror, I want to mirror them over the axis of symmetry. So if I look at my axis of symmetry, I ask myself, how far was it to my first point? Well, it was 1 point to the left. So now I'm going to start at my axis of symmetry, and I'm going to go 1 point to the right. Then I'm going to do the same thing with my point up here. This guy was 1, 2 from the axis of symmetry, so I'm going to go the other side, 1, 2, and draw my point. Now I can draw my parabola. Whoops. There we go. Okay, so that's an example of one in standard form. Let's do that again. This time let's look at number, how about number 7? Number 7, skill check on page 253. Number 7, skill check on page 253 looks like y equals negative 1/3 x squared minus 2x, sorry guys, minus 3. Okay, all right, so again, I know this is in standard form because I have ax squared plus bx plus c. Or a is negative 1/3, b is negative 2, and c is negative 3. Okay, so I have those pieces. Now, my first step is, does it open up or down? So I'm looking at A. A is negative 1/3, so it is less than 0 because negative 1/3 is less than 0. So this tells me it should open down. So already in my mind, I kind of have this picture. I know it needs to look something like that. It needs to open down. Okay, step 2 is my vertex. I don't know why I'm spelling that out, sorry. Okay, and I need to find my x coordinate, which it says negative b over 2a. So in our case, if you remember your a's and b's up here, b was negative 2. So the negative of negative 2 is going to be positive 2. And then you have 2 times a, or 2 times negative 1/3. So you'd have 2 over, this would be 2 over 1. So 2 times negative 1 is negative 2. 1 times 3 is 3. We can make that cleaner. Dividing by a fraction is like multiplying by the reciprocal. So we'd multiply by negative 3/2. So that would be, these would cancel. And I have negative 3 for my x. Okay, now to find y, you can sub this back in by hand, or you can use your calculator. I prefer using my calculator unless it's a really super easy x or something like that. Okay, but this has a fraction in it, so let's just go ahead and use our calculator. So type in, remember we went to y equals, I had to clear my other one out, and type in -1/3. I like to put mine in parentheses if I have a fraction like that. So -1/3 x squared minus 2x minus 3. And then I want to go to second, trace, value. Give your graph a little bit of time. And then it's going to ask for x equals. Remember, our x that we had up here was -3. So I'm going to type in -3. And it looks like it gives me y equals 0. So that means my vertex ordered pair is -3, 0. Let's go ahead and graph that. Okay, step 3. Step 3 is my axis of symmetry. Remember, it's set up here. We're going down, so just draw your axis of symmetry down. And guys, honestly, you saw what your graph needed to look like on your graphing calculator. So in the end, if your graph doesn't look like that, you've done something wrong. So I don't want you to just copy it off your graphing calculator, but that can be used as your guide as well. Step 4, we need an XY table. Remember, I can pick anything, so I could pick -2, -1, 0. I could pick anything over here, or I could pick anything to the right, but I want to make sure that they're either on the right or the left-hand side of the axis of symmetry, okay? I'm going to pick, it's sometimes easier, guys, if you stay closer to your vertex, so I'm going to pick -2 and -1, especially since I'm using my calculator. It's easier to type them in there anyway. Now remember, I didn't touch anything on my graphing calculator, so I can type these right in. But if you did, you need to go back to second, trace, and go to value again. And it'll ask for x equals. So I can type in -2. Oops, sorry, -2. It gives me -0.3333. I know I'm not usually fond of decimals, guys, but you're graphing this. So it's not like a solution answer or anything like that. I'm okay with decimals. And then I'm going to do -1. And I get -1.33333. So let's plot those points. -2, -0.3, and -1, -1.33. Okay. Step 5 is to mirror these. Remember, you're mirroring over the axis of symmetry. So this little guy was 1 spot to the right, so I'm going to go 1 spot to the left. This guy was 2 spots to the right, so I'm going to go 2 spots to the left. And draw my graph. Remember, it was supposed to open down, and it does. Okay, so there's 2 examples of standard form, and those were the first parts of your notes. The first part of your notes. Okay, so now let's look at a different form. Let's take a look at example 2. Example 2 gives us y equals -1/2 x plus 3 quantity squared plus 4. Now remember, you have 3 forms: standard form, vertex form, and intercept form. This one looks like this looks like vertex form because I have a quantity squared and a number out here to the side. Now, I don't necessarily have to have this number outside, all right? But the big thing I'm looking for is a quantity squared. If I see quantity squared, I know it's in vertex form, okay? All right, so we start off the same way. The first step is, does it open up or down? Well, let's take a look at our A. Our A is -1/2. -1/2 is less than 0, so that tells me this opens down. So already in my mind, I know my graph should look something like that. Okay, it's going to be pointing down like a hill. Step 2, vertex. Now remember, with vertex form, I've got a shortcut. It says in our notes that vertex form is whatever HK is, but H is opposite of what it looks like. So like if you line H up, it looks like H is 3. But because these two signs are different, that makes H opposite of what it looks like, because what that means is whatever H is has to give me positive 3. So I have minus a negative 3 would give me this positive 3. All right, so whatever, I think of it as whatever is in this spot, it's opposite of what it looks like. So my H would be negative. K is exactly what he looks like, so 4. So much easier than standard form. I have my vertex just by looking at the equation. Let's plot him. Okay, step 3, still my axis of symmetry. Everything else is going to be exactly the same. Axis of symmetry, we know it opens down, so it's a dotted line going down. And I know that looks like it's not important, guys, but honestly, if you mess up on your XY table, that axis of symmetry is going to tell you that. It's going to be a helper there to say, hey, your points are supposed to be going down like your axis of symmetry, and it helps you remember that, okay? No, it's not necessarily on the graph, but I need to see it, whether you think it's useful or not, okay? Number 4, XY table, just like the last one. Okay. Put it in. Oops, we got to pick some X's first. Donna, turn it down. Turn it down again, please. Okay, so here's my axis of symmetry. And I'm going to pick something close to it. So I'm going to pick negative 2 and negative 1. Okay, now let's type this equation into our graphing calculator. Remember, I like to put my fractions in parentheses. So I'm going to write, I went to y equals, I'm going to clear that out, and I'm going to type in negative, oops, sorry, I need that in parentheses, negative 1 divided by 2 in parentheses. Then I have my x plus 3 in parentheses, quantity squared, there's your squared key right there, plus 4. And I want to go to second trace value. It's going to ask me what x equals. Remember, we want x equal to negative 2. Gives me 3.5. Then it wants x equals negative 1. Gives me y equals 2. Okay, let's plot those points. Negative 2, 3.5, and negative 1, 2. Last step is mirror, just like it is in standard form. So this guy was 1 point away from your axis of symmetry. So I'm going to go 1 point to the left. This guy was 2 points from your axis of symmetry. So I'm going to go 2 to the left. Draw your parabola. So vertex form is a little bit quicker, but really only just for that one vertex step. Okay, let's try another one of those. Look at number, let's look at number 5 on page 253. Number 5. Number 5 gives me y equals 2 times the quantity of x plus 1. You know what? I changed my mind. Let's do number 8. Sorry about that, guys. So we've got y equals negative 3/5 times the quantity of x minus 4 squared plus 6. Okay, again, we know this is in vertex form because we have a quantity squared. So here's my a, my x minus h, and my k. First step is still the same. Does this open up or down? Well, a is negative 3/5 in our case. Negative 3/5 is less than 0, so that tells me it opens down. So I kind of have that hill shape in my mind that I know it's supposed to look like. Number 2 is vertex. Remember, for vertex form, we have a shortcut. It says that vertex should be HK, but H is opposite of what it looks like. So H looks like -4 here. It's actually +4. K is exactly what it looks like. K is +6. Let's go ahead and plot that. Okay. Step 3 is axis of symmetry. Remember, we said this was going to go down, so let's draw that dotted line down. And now I'm ready for my XY table. 2 points on one side of the axis of symmetry. It doesn't matter what they are. It's totally your choice. I like to keep it close to my axis of symmetry. So I'm going to pick 3 and 2. But I could have went over here and picked 5, 6 as well. That's totally your choice. Or I could have picked 0 and 1. Your choice. Now remember, I want to go to y equals. And I want to type this new equation into my calculator. So I'm going to put -3/5 in parentheses. Then I'm going to put x minus 4 in parentheses. Whoops, sorry, I put 2 x's in there. Then I'm going to square it, plus 6. Then I want to go to second, trace, value. Give it some time to graph. And it's going to ask me for x equals. I want to put in 3. It tells me y is 5.4. It says it right there. And then I want to put in 2. And it tells me y is 3.6. Remember, I don't need those as fractions. I'm okay with decimals because it's not like those are my answers. Those are just parts to get my graph. That's my answer. So I have 3, 5.4, and 2, 3.6. Step 5, I'm ready to mirror. This guy was just 1 away, so I'm going to go 1 to the right and line him up. This guy was 2 away, so I'm going to go 2 to the right and line him up. And draw my parabola. It was supposed to open down, and it does. So there's another example of vertex form. Okay, so now we're moving on to our last one, intercept form. Intercept form is on example 3. Example 3 is y equals negative of x plus 2, x minus 4. So obviously this isn't standard form because you don't have an ax squared plus bx plus c. It's not vertex form because you don't have a quantity squared. You have 2 quantities, all right? Or the way I think of this is you have 2 x's because sometimes, like if this was 0, they wouldn't have to show this whole quantity. They could just show it as x, but it's still intercept form. And I'll show you one like that here in a second, okay? All right, but this is intercept form because I have 2 quantities, and more specifically, I have 2 x's being shown. So this is my a. Yes, there's just a negative there, but remember it's a -1, even if I can't see it. Then I have x minus p and x minus q. Now remember, P and Q are just like H. They are opposite of what they look like. And we'll talk about that here in a second. First step is always the same. Does it open up or down? Well, remember our A out here, that's -1. And since -1 is less than 0, this guy opens down. We've had a lot opening down. I promise they do open up as well. Okay, step 2 is different. We don't do vertex this time. With intercept form, we find the x-intercepts. So my x-intercepts, remember they are P and Q. But remember what I said, P and Q are opposite of what they look like. So even though P looks like +2, it's actually -2. And even though Q looks like -4, it's actually +4. All right, and it's all because these guys have those minus signs. Because if you sub that -2 back in there, minus -2 would be a +2. That's how that works. Okay, now this is not an ordered pair. These are two separate x-intercepts. So we're ready to plot these, but remember x-intercepts go on the x-axis. So here's -2 and here's +4. So that's not an ordered pair. That's two separate points. Step 3, now we get to vertex. And for the x-coordinate, it says x is halfway between my two intercepts. Okay, so you kind of have to count like you do median, but don't forget this middle. Don't forget 0, okay? So if I cross off, or if I think in my head, okay, -1 to here, then here to here, then this would be my middle. 1 would be smack dab in the middle because I've got 1, 2, 3, and I've got 1, 2, 3 spots. All right, but remember, that's not where my vertex is. That's the x-coordinate of my vertex. Then to find your y-coordinate, it's just like always. You can put it into this equation up here. Now this one's not that hard. I wouldn't have to do it on my calculator. 1 plus 2 is 3. 1 minus 4 is -3. 3 and -3 multiplied is -9, and that would make it a +9. But let's just do it on our calculator to check it as well. So go to y equals, clear out that equation, type in your new one, negative of, you're going to have to wait till I'm done, please, of x plus 2, and then the quantity of x minus 4. And we want to go to second, trace, value. Sorry about the glare. And what was my x-coordinate? My x-coordinate was 1. And they tell me my y is 9. Okay, so we're good. So 1, 9 is my vertex. Now let's think about this. The next thing is axis of symmetry, just like normal. It better be going down so we can get these two guys involved in this parabola, and it says we should go down, so we're good there. And then when we go to do our x, y table, which is actually step 5 now, you already have the vertex and one set of mirrored points. So in your xy table, you actually only need one value this time. I try to keep it as close to my vertex as possible, but as long as it's inside my intercepts, guys, it should be pretty easy to plot. So I'm actually going to pick 0. Remember, I can use my calculator. And I get y equals 8. So I'm right here. And I can mirror him over. Remember, these guys have already mirrored. By plotting them, they are mirrored points. Okay? Draw your parabola. There we go. All right, so let's try another example of those. Let's look this time at number 9 on page 253, number 9. So number 9 says y equals 5/2 x times the quantity of x minus 3. Sorry, okay. All right, so you know that this is not standard form because you do not have an ax squared plus bx plus c. This is not this is not vertex form because I don't have a quantity squared. All right, the only thing left that this could be is intercept form. It's just that I can't see that other quantity, but notice I have this other x here, so what did he come from?
I can't get that fixed.
Okay, just a second, guys. Bring it over here, please. Bring that over here and I'll fix it. Okay, but what I can do is I can rewrite this as a quantity. So I have 5/2. I can make this guy into x minus 0, because wouldn't that be the same thing, x minus 0 or x plus 0? That would still be x. And then I'll carry him down as x minus 3. So now I can see that I have A, I have x minus p, and I have x minus q. Okay, so first step, always the same. Does it open up or down? My A is my 5/2. That's greater than 0. So this opens up this time. So I'm thinking this guy's going to look something like that. Okay, step 2, remember, is not vertex like normal. It's plotting your x-intercepts. So what is P and Q? And remember, it's opposite of what it looks like. So here, this, of course, looks like a -0. But guys, do you have a +0 or a -0? No, you just have plain old 0. And then for this one, this guy looks like -3, but he's actually a +3. Okay, just a second. Stop it. You don't want a picture on here at all? Is that what you're saying? Okay. Which one do you want to go to? Like that?
No.
I think that's going to be too hard. Why don't you...
That one.
There. Okay. What do you say? Okay, again, I apologize, guys. Okay, so let's plot this. Remember, these are x-intercepts. So they go on the x-axis. They are not in ordered pair. They are 2 separate points. So here's 0, and here's 3. They're 2 separate points. So then step 3 is finding that x-coordinate of the vertex. And remember, it's halfway in between here. Okay, so I go a spot from each, and then it's got to be halfway in between there. So it's a spot and a half from each one of them. So that would be at 1.5, or you could use 1.5 as a mixed number. I'm going to use 1.5 because I'm going to use my calculator. So I don't want to put a mixed number into my calculator. I can't put a mixed number in. All right. Remember, that's not where my vertex is. That's just the x-coordinate. So it's kind of like a reminder for me. Now I'm going to do my y, and I'm going to do my y by doing it on my calculator. So go back into your y equals, clear it out, type in, I put my fraction in parentheses, so 5 divided by 2 in parentheses. Then I have x, and then I have the quantity of x minus 3 in parentheses. I don't need to do the x minus 0, x minus 3. My calculator can read it as the original. Go to second, trace, value. And remember, my x is 1.5. That tells me my y is negative 5.63. And that's an ordered pair. That's an ordered pair. So I have 1.5, comma, negative 5.63. Sorry, that looks like 15, but that's 1.5. All right, so I've got this 1.5, and then I need to go to negative 5.63. Like that. Okay, step 4, axis of symmetry. Remember, this one was supposed to go up, so my axis of symmetry this time is going up, goes right through that x that I thought was my x-coordinate. Then I need to do my xy table. Remember, for intercept form, I only need one other point. So I don't have a lot of options for this one because I try to pick one between the x-intercept and my axis of symmetry. So I'm going to pick 1. It doesn't matter. You could have picked 2. You could have picked a decimal. You could have picked something out here. I try to keep it as close as possible. And if I use my calculator and ask it, what do I get when I put 1 in? It tells me negative 5. So over 1, down 5. Then, of course, for step 6, mirror that guy over. So we were right here. Now careful this time because he's actually just a half spot away from that axis of symmetry. So I just want to go to half spot again. And then I'm ready to draw my parabola. Okay, try to make it as U-shaped as possible. I have a lot of kids that try to just make them a V every time. They are not Vs. Absolute value graphs are Vs, and we don't want to make them look the same. Okay, so try to make it U-shaped. Okay, so there's a second example of intercept form. Those are your 3 graphing, all right, and you practice all 3 of those. Make sure you're practicing all 3 of those. That's a big part of your test. If you take a look at example 4, Example 4 stops graphing for a little bit, and it talks about writing something in standard form. Remember what standard form looks like. It looks like ax squared plus bx plus c. And so what this is saying is it takes vertex form or intercept form, and it wants to put it into this form. So example 4a looks like y equals the negative of x plus 4, x minus 9. In our notes, we wrote down to put something in standard form, we have to use a method called FOIL. And FOIL stands for multiply the first terms, multiply the outside terms, multiply the inside terms, and then multiply the last terms. FOIL, first, outside, inside, last. Okay, you always want to FOIL first because you know with order of operations, you're supposed to take care of your parentheses, you're supposed to multiply first. So we've got to do this before we can even take care of that guy. Okay, so let's do that first. We're going to leave that negative out front, and we're going to make a new set here. X times x is x squared. Okay, now we're doing outside. X times negative 9 is negative 9x. Then we're doing inside. 4 times x is 4x. And now we're doing last. 4 times negative 9 is negative 36. Now, we can clean that up a little bit more because you've got like terms right here. So, you've got x squared, but then negative 9 plus 4 would be negative 5x's minus 36. Remember, x squared and x cannot be combined. They are not like terms. Now that I have this cleaned up, now I can distribute this guy out front. So now I have negative x squared plus 5x plus 36. That's in standard form. Ax squared plus bx plus c. Okay, now let's take a look at example 4b. Example 4b is originally in vertex form. So the last one was in intercept form. This one is in vertex form. And they want us to put it in, they want us to put it in standard form. This is a little bit different because we have a quantity squared. And a lot of times, kids will want to take that square and they'll just say, oh, we just square the x and square the 1 and we're done. Okay? I know I'm not standing beside you, but I would want to take a ruler and smack your fingers if I saw you do that. That's not okay with me. That's one of my biggest pet peeves. Okay? Remember what a square means. A square means that you have 2 of them. So if I have a set or a quantity squared, that means I have 2 of those quantities. So what I actually have to do is write them again. And I'm not allowing myself very much room here, so I apologize for that. Okay, but I have x minus 1 and x minus 1. So again, just like on your other one, what was the first thing we needed to do? We needed to take care of our parentheses and we needed to FOIL. Okay, so 3 is going to stay out front. First terms, x times x is x squared. Outer terms, x times negative 1 is negative 1x. Inner terms, negative 1 times x is negative 1x. And last terms, negative 1 times negative 1 is positive 1. Then I have my plus 8. I can still clean up here because I've got like terms right here. So I've got 3 x squared. I've got negative 1x and negative 1x, which would make negative 2x. Now, which one am I going to do? Am I going to distribute or am I going to add this 8? Order of operations says I have to multiply before I can add. So I need to distribute that 3, which would give me 3x squared minus 6x plus 3. Then I can add my 8. I've got like terms right here because they're both constants. So y equals 3x squared minus 6x plus 11. Ax squared plus bx plus c. So now I have it in standard form. Okay. All right. Now we can practice that. Let's look at How about number 11? We'll do number 11. Actually, let's go nuts. Let's do number 14. That way we deal with a beloved fraction. We'll do number 14 first here. Okay, number 14, and again, the directions don't say to graph. They say to put the write the quadratic function in standard form, meaning they want it in ax squared plus bx plus c. And on number 14, they give us y equals negative 1/2 x minus 6, x minus 8. Okay, so remember, I want to FOIL first. I want to take care of my parentheses first. I leave this guy alone. So negative 1/2 is going to stay out front. Then I have x times x is x squared. Outside terms, x times negative 8 is negative 8x. Inside terms, negative 6 times x is negative 6x. And last terms, negative 6 times negative 8 is a positive 48. I can clean this up a little bit because I've got like terms there. So I've got negative 1/2 x squared, negative 8x, and negative 6x would be negative 14x. Then I can distribute this. Don't freak out. I think we can take half of it. Y equals negative 1/2 x squared. Half of 14, two negatives make a positive 7x. Half of 48 is 12, and a negative and a positive makes a negative 12. Now I have it in standard form, ax squared plus bx plus c. Okay, now let's try another one from vertex form. Let's go number 15. So we do another fraction. Y equals 2/3 x minus 9, quantity squared, minus 4. So they're making us go from vertex form again. Remember, this does not mean just square the x and square the 9. Okay, that means there are two of those quantities. So let's write them. There's actually a shortcut for it, but so many kids forget it that I would just much rather you write it again and FOIL it. Okay, this 2/3 is going to hang out front. We have to take care of our parentheses first. First terms, x squared. Outer terms, negative 9x. Inner terms, negative 9x. Last terms, positive 81. Okay, then I can distribute this. Now I know this is going to be a little more difficult. Oh, shoot. Before I distribute, sorry, let's back that up. Let's back that up. I can combine these first. So that would give me 2/3 x squared minus 18x plus 81. Then I can distribute this 2/3. Now I'm ready. Okay. So I've got 2/3 x squared minus, don't freak out on this, you could do this in your head, okay? 2 times 18, okay, maybe you don't know that. Let's go the other way. 18 divided by 3, that's easy, that's 6. Now take it times 2. 6 times 2 is 12, needs to be a negative. Guess I already wrote it in there. 81, now this one might be a little more difficult. 81 divided by 3, ooh, shoot, maybe we don't know that. 81 times 2, ooh, shoot, maybe we don't know that. So what? Do that on your calculator. What's 81 divided by 3? That's 27. 27 times 2, 54. Then I have minus 4. Oops, I forgot my square. Sorry about that. Now I can combine these guys. So I have y equals 2/3 x squared minus 12x plus 50. Now I have ax squared plus bx plus c. Okay, so that kind of gives you a break from graphing. That gives you a break from graphing. All right. Now, the last piece of this, guys, is using this for real life situations. And the great piece of this is it looks tough. It's really not tough. Okay. Example 5, and I'm not sure you can see this very well on my calculator or on my notebook paper, but I guess I wanted to show you where it was at. Let me pull my board back over here. This will be better. Okay, remember when you guys were writing your notes? When you were writing notes for standard form, it said something about real life. It said a vertex is the highest or lowest point of the parabola. Okay, it's a maximum or it's a minimum point. Well, that's what it is in real life as well. Okay, so if you take a look at example 5, example 5 talks about researchers conducted an experiment to determine temperatures at which people feel comfortable. It says the percent Y of test subjects. So I always write that kind of down so I know what that means. So Y is the percent of test subjects the percent of Y test subjects who felt comfortable at temperature X. So X is my temperature. So I have both of those written down. And then it gives me this equation. Y equals negative 3.67x squared plus 527.3x minus 18.807. Okay? And then it asks what temperature made the greatest percent of test subjects comfortable, and at that temperature, what percent felt comfortable. Okay, as soon as you hear that word greatest, biggest, most, maximum, that means it's the very highest point, because think about this parabola. As soon as you see it start with a negative, you know that it opened down. So then where would I find my very highest point? I'd find it right here, which we call the vertex. And how do you find vertex of this? Well, it's in standard form. You have ax squared plus bx plus c. Here's my a, here's my b, here's my c. So let's find the vertex. X equals negative b over 2a. Well, in our case, remember, b is 527.3. So it's negative 527.3 over 2a. Our case, a is negative 3.678. Let's do this on our calculator. I would clean up the bottom first. 2 times, sorry, I'm trying to get rid of that glare. 2 times negative 3.678. I get negative 7.356. Then I want to do negative 527.3 divided by answer. And I get 71.68. Okay, so there's my X. Now how do you find Y? Just like we found Y when we were graphing. Put this guy into your calculator and go to second trace value. So we're going to go to Y equals, and we're going to type in our equation. Negative 3.678x squared plus 527.3x minus 807. And I'm going to go to second trace value. Now, when you get into story problems, this is when your window might not show up, okay? Sometimes it'll work and sometimes it won't. Like right now, I can't see my parabola, but I know I typed one in, okay? All right, now, when I type in 71.68, it says invalid. Well, let's think about that. If you go to your window, we are trying to put in 72, if I round it. We're trying to put in 72 for my X, and our X max right now is 10, so it's not high enough. So let's just throw in 100 there, okay? Now let's try it. So let's go back to second trace value. I still can't see my graph, but because I hired my x-axis or my x-max, there's a chance that it'll take my point. It's just that my graph is so far up here or so far down here that I can't see it. Okay, and if that wigs you out, then change your y-min and your y-max. Like you could change this to -10 and 100. Well, crud, I still can't see mine. I should be able to. I should be able to see that. What did I change my y? Well, let's put in my negatives. Let's put in my 71.68. That's not right. What did I forget to put in here?
10.
Oh, well, that's not 8. There's my problem. Sorry, guys. This says 18. This is 18,000. Maybe you guys already picked up on that. I apologize. This is 18,807. And I thought it was 18 point. Okay, so 18,807. Okay. I wanted to see my graph better, so I put my y max at 100 and my x max at 100 and my y max 100, so I could see a little higher and a little farther to the right. Okay, now let's go to second trace value. All right, now I can see my graph. Okay, I didn't need to, but I can. 71.68. It tells me my y is 92.22. All right. So there's my maximum, there's my vertex. So now let's go back and talk about what that means. Remember, that's why we wrote this up here. What does your y mean? Your y means your percent of subjects. And when you see a percent, it could be 2 decimal places. It wouldn't wig me out if you just had 92, because that's how you guys see your test grades usually. Sometimes I'll give you like 92.5 or something like that, but I'm okay with 92%. So 92% of your test subjects, and what temperature are they comfortable at? 72 degrees. There's my answer. Okay, and you could have written it the other way. You could have said at 72 degrees, 92% of your test subjects were comfortable. So that vertex is your most important part. When you see that greatest or maximum, that's your important part there. Okay, let's take a look at example 6. Example 6. Example 6 says the Golden Gate Bridge in San Francisco has 2 towers that rise 500 feet above the road and are connected by suspension cables as shown. Each cable forms a parabola with an equation, and it gives us this equation, y equals 1 over 8,960 times x minus 2,100 quantity squared plus 8. Okay? Now, we're still going to think of this as x. If you think about that Golden Gate Bridge, x is going to be my distance this way. Y is going to be my distance vertically. All right, if you look at that picture on page 252, okay, you can kind of tell that that's pretty easy. So then on part A, it says, what is the distance D between the 2 towers? All right, in just a second, I'm almost done. What is the distance D between those 2 towers? Okay, so here's my 2 towers, and here's my parabola, all right? So what do we know about that? Now remember, I said most story problems, guys, most story problems are going to deal with your vertex. And let's think about that. Where is vertex at? Vertex is at smack dab in the middle. Well, if it's smack dab in the middle of those 2 towers, if I found my vertex, then I would know this distance. So then I could double it and find the whole distance. Okay? So what form is this in? It's not in standard form. Okay? It's in, what do you need? I am almost finished.
Oh, my little screwdriver.
I don't know where your little screwdriver is, okay? Maybe check the laptop cart. That's the last place I saw you hide it. Sorry, guys, I'm going on 54 minutes. He's been pretty patient. Bear with us. Okay, so I know this is in vertex form because it is a quantity squared. All right, so if I think of this as a x minus h quantity squared plus k, I don't have to do near the work I had to on example 5. I can look at that problem and say, I know my vertex is 2108, opposite of h and k. All right, so then let's think about what that means. Well, my x, remember, is horizontal distance. That means that this is 2100 right here. So that means this is 2100 as well, the distance from here to the vertex and the distance from the vertex to here. Okay, so that whole distance, obviously, is 4200. And in the problem, it said it was measured in feet. Okay, part B says, what is the height L above the road of a cable at its lowest point? Well, the cable was right here. Or sorry, the cable is right here, and here's the road. And if you think about that in terms of, height, the road we think of as 0. So then how far was this road at 0 to my vertex? Well, that's a vertical distance. We have a vertical distance right here. You would have gone over 2100 and up 8. So this little spot right here is 8. And remember, it's 8 feet. Okay? So, like I said, remember, real life situations deal with the vertex. They deal with the vertex. They are not necessarily just what the vertex is, all right? But a lot of times you will start with the vertex and be able to answer questions from that using the vertex. Okay? All right. That gets you ready for your homework. So, good luck. Thank you for bearing with us. Donovan, do you have anything to say? You want to wave to my students? Say, see you next time.